Particle physicists look at the fundamental constituents of matter. As far as we know, the most fundamental particles don't have any size. So you might ask, how do they interact? If you can imagine 2 billion, them like billiard balls bang and then bounce off. But if something's got no size, then that doesn't make sense. But quantum mechanics saves us and says, well, actually, they can interact, if you like, by sending out waves. And those waves actually have particle-like properties. So if we have an electron and another electron, both with electric charge, they interact by exchanging particles which we call photons, just little packets of energy. Now, so any field, like an electric field, magnetic field, is actually on a quantum level made up by lots of little packets being exchanged all the time. One of the problems we have is that we don't understand why the particles that we know about have mass. Mass slows you down. So if you don't have mass, you travel at the speed of light, and our universe is clearly not one in which everything travels at the speed of light. One possible solution, which is favoured by theorists for an awful lot of good reasons, is that the universe is full of a field called the Higgs field. If the Higgs field permeates the universe, then there must be a particle associated with it, because that's how we understand fields when we look very closely at them. And if that particle is there, you ought to be able to discover it. So a massive particle propagating through the universe is continually emitting and absorbing Higgs bosons, and that process slows it down so it moves slower than the speed of light.